Hi everyone, I'm very glad to introduce you our work on generalizable, context-rich manipulation, which based on our previous work KPAM. When we think about manipulation tasks, at least one way is to follow an increasing complexity of the task request that we would have made. We might start from pick up any objects, that's robot grasping. We might also interested in pick up a specific object or put an object to a specific configuration. Eventually, we might want something like robot clean up a kitchen. But other than complexity, at least another dimension we might consider is a generalization of robot manipulation pipeline. It turns out that grasping algorithm can generalize to almost arbitrary objects, for instance the pretty cool GPD here. While the Boston Dynamics kitchen demo is also very cool, we are unsure whether it works for another kitchen with some new object. The human, which is both dexterous and generalizable, is our goal at the bottom right corner. In our previous work, KPAM, we take a step towards this goal by exploring category-level pick and place manipulation. For instance, the robot will pick up any instance from the marked category and place it on a rack. In this work, we still want the manipulation pipeline works for a category of objects, but to accomplish more challenging tasks beyond kinematic pick and place. In particular, we want closed-loop perception-to-action robot manipulation for precise context-rich tasks. At the same time, the pipeline should automatically generalize to a category of object despite significant shape or size variation. Of course, we are not the first to study vision-based context-rich manipulation. In particular, many works learn a visual motor policy using data-driven algorithm. However, how to efficiently generalize the trained policy to new objects or task setup remains an active research problem. Another series of work integrate a real-time pose estimator with closed-loop control. However, if we directly deploy this method to potentially unknown objects, we are facing the same problem as KPAM, that is, a valid pose trajectory for one object can be physically infeasible for another instance. One more option may be we directly use the pick and place policy in KPAM to context-rich tasks, but that doesn't work because the action representation in KPAM is limited to a rigid transformation of the object, which is no longer correct. Thus, we might need a new formulation. Let's consider it using package insertion as an example. We want the package insertion policy generalized to a new pack in B and a new robot grasp pose in C. Following KPAM, we would use a set of schematic 3D keypoint as the object representation. Suppose we just use this two. But our task is definitely depends on the relative orientation, thus we add orientation information into keypoint as if a rigid coordinate is attached to each keypoint. Here is what it looked like in our experiment. Using the oriented keypoint as the object representation, we propose the action representation as either the desired linear angular velocity of oriented keypoint or the desired force torque on oriented keypoint. We just established the object and action representation. That would be the input and output of our closed-loop policy. Importantly, task-unrelated geometric details of the object are transparent to our policy, for instance, the shape of the pack handle. This enables category-level generalization despite significant shape variation. Additionally, some other components are desirable for good performance and generalization. For instance, we would like to retarget the policy to different robot grasp poses and different initial configuration. Some robots are equipped with force torque sensor. We would like to use this information, but without violating the category-level generalization. Of course, we also need a robust real-time keypoint perception algorithm for closed-loop control. Furthermore, although this work focuses on context-rich tasks, pick and place is used to singulate the object. Can we do pick and place with oriented keypoint? Could it be much simpler than the original KPAM? Please refer to our paper for more details. For the last minute, I will devote it to video demo.